Hey guys, so we are going to do some review from this unit and just practice all of the concepts that we've learned, put them all together in some of these problems. Since nothing's new for each of the different problems, I'm going to ask you to try it and then I'm going to go over the solution. So starting with this problem, go ahead and pause the video and solve the problem. Come back when you're ready to see the solution. Hopefully you are all set and ready to see the solution. So I'll take you through how I think about it. Maybe there's other ways to think about it too. It's telling me over here that X, Y, and Z are all parallel lines. So here we go. So I can see that there's a transversal that cuts through all of them right here, which means I see three different clusters where things are going to be equivalent to each other. So I can demonstrate that here. So like this angle in blue is vertical with this angle, so those two would be congruent to each other. And then let's see what color will stand out. Orange. This angle and this angle will be congruent to each other because they're vertical angles. And then that cluster, I can move down. This and this will also be the same as those other two orange angles, as well as this and this. And then the blue angles work the same way. This angle and this angle will be congruent. So all of the blue angles on the page will be congruent and all of the orange angles on the page will be congruent. So where this helps me would be right here. I could see that this guy and this guy are congruent. They're both blue angles. You could also think about them as alternate exterior angles. If you're looking at these two parallel lines with the transversals, they're alternate exterior. So the first thing I'm going to do is set those two angles equal to each other. 16.6x minus 2.1 equals 13.5x plus 8.4. And I would solve that equation. When you solve it, you get x equals 3.387. So obviously there's work in between, but I'm just not going to waste your time and show all that work. Once I have x, I can find what the value of those two angles are. So I'm going to substitute x in. 13.5 times, instead of x, I'm going to say 3.387 plus 8.4. And when you solve that, you get 54.1245. So that's what this angle is equal to, 54.1245. Now, if I focus on this green line over here, I think what I might do is draw it off to the side so you could see it. So I have this green line, and there's these two lines coming off of it. Here's 58.4. Here's angle A. Here's 54.1245. They all form a supplementary relationship together. So all three of those angles together add up to 180. So what I can do is set basically an equation up. 54.1245 plus 58.4 plus A equals 180. Do your algebra, show all your work, and you end up getting that A equals 67.4755 degrees. And it would have the degree symbol there because angle A is its own angle. All right, one down. Go ahead, pause the video, try this one, come back when you're ready to go over it. All right, hopefully you are ready to go over it. Let's see what information we were given. So it looks like there's two slant heights. Coming down this side is S1, and coming down this side is S2. Sometimes you'll have different slant heights if the base is not a square. If the base is a square, all the slant heights are the same. And what I think might be easy for me to explain it to you with is drawing the net. That's a little too big. So here is that base. It's kind of rectangular. I maybe drew too much of a square, but we have side L and side B. And then we have this triangle and this triangle. Those two should be the same. And both of these have one of the slant heights. That's S1. Because you could see in the picture that that lines up with the side with the L on the base. And then I have these two triangles coming off. Those two will be equal to each other. And maybe I'll switch to a different color now so we can see it. So this is going to be S2. Because S2 goes with the side with B. So that's kind of how this triangle looks. And then there's a third dimension that's kind of behind S1. That's the height of the pyramid. This goes from the apex of the pyramid, the top of the pyramid, and it makes a right angle with the base. So I can't draw that in my net because that's only visible when the pyramid is folded up, but it would meet the base right there. That's where the height meets, but it comes straight up. So that's kind of what's going on here. Now I know S2 is 9.4 centimeters. So let's put some of this information in. So this is 9.4, this is 9.4, this is 9.4. They're all 9.4. And I want to find the height of the pyramid. So I'm going to turn this pink line into a right angle. There's so much going on here. So I'm going to draw an orange line right here. And then I have a right angle. I'll reconstruct that right angle. Here's my orange line. Here's my pink height. And here's my yellow S2. So this is this is S2, and that's 9.4. This is H. And then the orange line is half of side L, because L goes all the way across, and the orange line is half of that. So 1/2 L. And I'm doing this problem live with you guys, so I'm not exactly sure how everything's going to work out. Let's see what other information we got. Okay, so the next thing is the area of the square base is 64.6 centimeters squared. So it actually is a square. So B and L actually are equal to each other. So I don't know why they bothered giving us the two different measurements. So basically, in order to find what B and L are, you just have to take the square root of 64.6. So the square root of 64.6 is approximately 804. So I'm going to put all that information in. So B is 804, L is 804, which means that S1 and S2 are really the same. And then in order to find half of L, I need to do 804 divided by 2, and that's 402. So I can put that down here, 4.02. So now I have two sides for the Pythagorean theorem, and it looks like I can go from here. So in my Pythagorean theorem, I'm going to have a squared plus b squared equals c squared. C is going to be my S2. That's going to be the 9.4 squared. A and B, it doesn't matter which is which. One of them is going to be 4.02 squared. One of them is going to be h squared. Go ahead and solve that, and you would end up getting h is about 8.5 centimeters. So a lot of thinking, but not actually a lot of math. All right, and one more. Go ahead and try this problem. Come back when you're ready to go over it. All right, so I'm going to go ahead and plot the points. So A is at 5, -6. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So there's A. And B is at -3, 2. 1, 2, 3, 1, 2. Here's B. Draw the right triangle you would use to find the distance between the 2 points. So the distance between them is always the hypotenuse. And then you could either draw the triangle kind of above it or below it, but it'll be the same either way. So here's my right triangle. And then use the right triangle to find the distance. So I basically want to find out how far away the x's are from each other and how far away the y's are from each other. The x's, I see that those are 5 and -3, so those are 8 apart. That means that this side of the triangle is 8, the horizontal distance. The y's are -6 and 2, so the y's are also 8 apart. That's this distance. That's the vertical distance. So now I have a squared plus b squared equals c squared. Obviously, it doesn't matter where the 8's go because they're the same number. C squared is going to be the actual distance between A and B, the pink line I drew. So this distance is C. And when you solve that, you get C equals 11.31 units.